Hello guys, welcome back to a new video from the channel. Today I want to share with you a definition that it's called scale out and to show you how can we use that definition in order to hit more services in an architecture. So at the beginning I want to share with you a little introduction. After that I want to explain and show you a little example about our topic, and after that how can we improve this example, and finally how can we use the definition of scale out in order to improve our architecture that we improved in the previous step. So I want to share with you that there's a lot of ways to implement this definition, and I want just to share with you the theoric part of it, and maybe in some future videos I will show you how to implement this scale out definition. But in this part, in this video specific, I want to share a little theoric part of it. So it's up to you to decide how to implement this definition, okay? So to understand a little introduction, that if you want to have a basic performance, your code maybe won't be so complex. So in order to increase your performance in your code, in your architecture, and in your software, maybe, and probably it's true, your code will also increase the complexity. So you need to think about that in order when you want to think about improving performance, because you need more knowledge, you need to use more features of the language that you are using. So it's not really strange to increase the complexity of your code if you want to increase the performance of the architecture. Okay, just a little introduction that I want to share with you. So you don't need to be afraid about that. It's normal. So I want to start about our example, and in this case I want to share with you a single thread operation. So for example, we have a client, a customer, that sends a request to a service A. After that, service A have three operations that need to send to a service B. But in this case, service A sends one at a time the three operations with the three requests that needs to be sent to service B. It will be sent one at a time. So the first request will send to service B will process. After that, service B will answer with a successful response to service A. After that, the second request will be sent to service B. Service B will process that operation, and after that, service B will respond with a successful response, and after that, service A will send the last request to service B. Service B will process that last request, and service B will respond with a successful operation, and after that, service A will respond to the customer that the operation was successful. So in this case, it means that service A processed that request in a single thread and send to service B all the requests in a single thread, one at a time. So if the operation had a cost of 300 milliseconds, we had three operations, and in totally our operation had a cost of a time of 900 milliseconds. So how can we improve this? So we can use parallel processing. It's a mindset that some software designers and developers have, and in this case the same as the last, that a customer or a client or a caller, so we can say a caller, sends a request to a service A, and after that, in a parallel way, service A sends the three requests at a time to service B. Service B sends the three requests at a time and save that data in the database, and after that process, service B responds in after they process each request, the response to service A, and service A responds to the customer that the operation was successful. And if we have at the same time the operation with 300 milliseconds of time, the total time of the operation, if indeed it was in a parallel way, in a parallel processing way, the total cost of this operation was 300 milliseconds. Maybe the number can be a little different if service B does not process at the same time the request from service A, but in order to show about parallel processing, I try to show you that if indeed it was in a parallel way, so we can say that it was just one request instead of three requests in a single thread operation. So we need to think about something important, that in the previous slide I show you that service B processed the three requests at the same time, but maybe there's some occasions, some context that service B could not process the three requests at the same time. Why? Maybe service B is in another infrastructure with a little less of CPUs or memory, I don't know. So it is important, in order to achieve that processing, to scale out service B. And what it means scale out? How can we improve this architecture? So in this case we have two service B services. So an API gateway or load balancer that is in front of service B will redirect that operations as some criteria of the load balancer of the layer that it's before calling service B. So in this case, service B sends the three requests to a, for example, load balancer, and the load balancer decides for which service B will attend that request. And after that, after services B process that operations, they will save the data to the database, and service B will respond to service A, and service A will answer to the caller. So in this case, scale out means to have more services about service B in order to improve the process performance. So scale out, we can scale to many services that our infrastructure can uh, can achieve in order to improve the request. So it's a very good definition to consider in order to have a healthy architecture. So thank you very much for the attention, and please subscribe to motivate me to record more videos, and please like below in the video that you to show me that you like the video. Bye bye.